Okay, Algebra 2, we're going to skip over section 7.4 for now and move on to 7.5. It's just a little bit easier for me to teach you when I'm not there. So 7.5 is all variation functions. Sorry, I'm losing my voice. Hold on. Okay. That didn't really seem to help. Variation functions. There are 4 different kinds that we're going to talk about, 4 different kinds of functions. First one is direct, and you can, like if you notice these boxes, those are the functions that we're going to be doing. So direct function, a joint variation function. Then we have inverse is the third type. Also right in here, sometimes they will call it indirect. Okay, so if they say inverse or indirect, those mean the same thing. And then number 4 is a combined variation where they're doing like 2 of them together at one shot. Okay, so those different types of variation functions, and these kind of like model like real life scenario problems. So like here's an example of a variation function that we would have where they're talking about the length of a ramp on a like a skateboard ramp versus like the length of the platform, or the height of the ramp versus the length of the platform that there should be. Okay, so when building skateboard ramps, Scott determined that the best ramps were the ones in which the length of the top of the ramp was 1.5 times as long as the height of the ramp. Okay, so like if this was 1 foot, this would have to be 1.5 feet. Or if this was, let's say, 10 foot high, this would have to be 15 feet long, okay? And so there's a lot of science that goes into stuff like that because as you're going along, like if you're on a skateboard and you go up, if they don't have this thing long enough and it's too short, you're going to go up and you're going to come back down and you're going to be all like already landing at the end of this ramp, right? Like instead of you want to go up and you want to come back down and land directly at the top of the next ramp so that you can go down nicely. But like if it's too short, then you'll land like all the way over here on the end of the ramp. Okay, if it's too long, you'll go up and you'll come back down and you'll land on the platform, and then you'll have to like scoot over and then get off again, right? So you want to have it like kind of down to a science of like where that should be placed so that you go up, you come back down, and you're just right on the next ramp again. So it makes it really nice. Okay, so 1.5 times as long, and this is a direct variation function. So they're saying that the length of the ramp is 1.5 times the height of the ramp, and that's the way direct variation works. Okay, you have 2 variables, y and x, and then you have a number that's associated here, and this is called the constant of variation. Okay, and so in this case that number is 1.5. It won't always be 1.5. Sometimes it'll be a different number, like y equals 2x, where k is 2. The constant of variation is 2. Here is y equals 1/4 x. Okay, here is variables like c for circumference. So this is circumference for circle, and then that's directly related to the radius. And in that case, your k is the value 2 pi. Because pi is just a number, right? So 2 pi would also be a number. And so this is the value of k. That's your constant of variation. So those are all direct relationships or direct variation. And one thing you'll notice, at least with these two, is those are just linear functions, right? If we were to graph them, they would just be linear relationships like this one is, right? That's just a linear function, okay? So direct relationships will work that way, all right? When you're doing direct variation, the first thing that you need to find is what that constant k is, that constant of variation. So the way we're going to do these problems is we're going to separate them into steps. So it says if y varies directly as x, that is defining our variables. So that means y equals k times x. Okay, that's going to be my like first step, is like what variables are we using? Because sometimes down here they might be using z instead, or different variables like length, width, and height. So we need to define our variables. So we know that if it's varying directly, we need y equals k times x, okay? Just like in this equation up here. That's what we're going to start with, okay? The next step is it says y is 15 when x is -5. So I'm going to plug those in to what I have right now. And if y is 15 and x is -5, I can use that to solve for k. So to get k by itself, I would divide by -5. Okay, and then k is going to end up being -3. All right, so that's my middle step. My middle step is going to be finding k. So first I want to write out the equation. The second thing I want to do is find k, like our constant. Like, what is that number going to be? And then I'm going to use that. So I'm going to rewrite this with the k in there. I'm gonna like rewrite this equation with the k in there. So I know that y equals -3 times x. Okay, I've solved for k. I know that the constant, the thing that's going to stay the same, is going to be -3. And then it says, find y when x is 7. Now I'm going to actually solve for what I'm wanting. So I'm going to plug 7 in for x, and y is -21. Okay, so I'm going to say solve for what you want. Like here we're wanting to find y, right? So that's a 21. Okay, so kind of in 3 steps. First, we're going to write out the equation that we're going to use. Second, we're going to solve for k. And then the third thing, we're going to solve for what they actually ask us to solve for. Okay, so that was an example using direct variation, but it's going to be the same process for whichever variation we use. This next one is called joint variation. Okay, and joint variation is going to have 3 variables. So we have a y, and we have an x, and we have a z, and we still have that number k that's here. K is that constant of variation. It's just going to be a number. So like here is an example of like y equals 5xz, or force equals mass times acceleration, where your constant there is 1 in that case. Volume equals length, width, height. This is an example where we have actually 4 variables, right? My constant is the number k, but length, width, and height, those 3 things are joining together to make the volume, okay? So we kind of have 4 things there. So joint variation could be like a multitude of different variables. It didn't have to be just 3, like here was 4, okay? So the reason why it's called joint variation is because like here the x and the z are having to join together to make up what the y value is, versus in direct, it was just x was directly related to y. There was only 1 variable on this side and 1 on this side with the k, okay? So here it's joint because these have to join together to make the value of y, okay? And joint variation, because it has 3 variables, is going to be like a 3-dimensional graph, okay? So it will be a linear function, but it will be a line in 3D space. So it'll actually have like an x, y, and z axis. We won't get into that right now, but that is what joint variation will look like, okay? So let's go down and answer this question. We're going to, again, have our 3 parts. So here we're going to define the equation, and we're going to solve for k. Then we're going to solve for what we want. Solve what we want, okay? All right, so our equation, suppose y varies jointly with x and z. That means we're starting with y on this side, and x and z are going to be over here, but we need to make sure we have k in the spot there. So that's what my equation is going to look like. Y varies jointly as x and z, okay? Now, the way that they have this worded is they say find y when x is 9 and z is 2. That's solving what I want. So they're giving me stuff over here. So I'm going to put that in this little spot. Find y, x equals 9, z equals 2. I'm going to put that in this spot, and we're going to hold on to that until we have our k solved for. It says if y is 20, so I'm going to say y equals 20 when z equals 3 and 3 and x equals 5. I'm going to use this information to plug in here and solve for k. That's what I have to do first, okay? So they're kind of giving me like everything backwards. I'm finding y. I know that's what I want to find. So I have to put that in my 3rd step. So they're kind of giving the information to me backwards, okay? So I'm going to plug those numbers in here. I know y is 20. K is what I'm solving for, so I'm going to leave it as k. And x is 5 and z is 3. Okay, so 5 times 3 is 15, and if I divide by 15, that will give me what k is. And let's see, 20 divided by 15 is, I don't know, I could divide both of those by 5, so 4/3. I'm going to leave it as 4/3. It's like 1.3 repeating is what k would be. So I'm going to leave it as 4/3 because that's what 20 over 15 will reduce to. So now if I go over here, I know that y equals 4/3, that's the k, times x times z. And all I need to do is just plug these numbers in and solve for y. So 4/3, x is 9, z is 2. And I mean, you can type that into your calculator if you want to. 4/3 of 9 is actually going to be 12, I think. And 12 times 2 is 24. So you can type that in if you want to. Or 4/3 of 9 is 12, and 12 times 2 is 4. That will work. So the ultimate answer is 24, but taking the steps to get to there was that K was 4/3. All right, let's go to the backside. This next one is called an inverse variation or direct variation. Yesterday, we actually learned what the graph of these look like, and this is the reciprocal. Reciprocal, and the reciprocal was y equals 1 over x, okay? So the only difference is that that number might not always be 1. It might be 6, like this one is here. Or like here they have volume equals temperature over pressure. That's an example of an inverse variation. Or the time that something takes is the amount of work we need divided by the number of people, okay? So yesterday we had an example of like the time that it takes to fly somewhere is equal to the distance, which we had like 9,000 divided by the speed, right? And it looked something like this, right? So those are reciprocal, those are inverse variations. So they'll say that it varies inversely, or they might say indirectly, okay? So again, we're going to have our 3 steps where we write our equation, we're going to solve for K, and then we're going to solve for what we want, okay? All right, so starting with our equation, we're going to define the variables. So it says A varies inversely as B. So we're not talking about y and x anymore. We're talking about A being equal to K divided by B. So it's like A is in the y spot and B is in the x spot, okay? A equals K over B. That's what our equation is going to be, okay? It says A is 28 when B is -2. So I'm just going to plug those in. A is 28. B is -2, and then I'm going to use that to solve for K. So if I'm trying to get a K by itself, let's multiply by -2. And -2 times 28 is -56, and that's what our K value is. Okay? All right, then I'm going to go over here and solve for what I want. So I'm going to rewrite everything. A equals, right here, like just rewriting this, -56 over B. And it says find A, so that's what we want to find, when B is -10. So I have -56 divided by -10, and that is going, the negatives are going to cancel. 56 divided by 10 is 5.6. So that's what the value is going to be of A. That's what I'm wanting to solve for, okay? So same 3 steps every time, no matter what type of function you're doing, all right? Here's another example of an inverse variation, but this is actually a story problem. So the length of a violin, okay? We need to use a variable to represent length. So I'm just going to use this cursive L. So the length of the violin varies inversely as the frequency. Let's call that F of its vibrations, okay? So we have length varies inversely with the frequency. All right, that's going to help me get my equation. All right, length varies inversely or indirectly as the frequency. So I have y equals K over X, but instead of y, we have length varying inversely. That's still going to stay K. With the frequency. So F is going to go in the bottom, and I still have to find what K is, but we have L and F instead of Y and X. Okay, so that's my equation. All right. A violin string 10 inches long. That sounds like length. That sounds like length is 10. Vibrates at a frequency of 512. So F is 512, and I'm going to use that to solve for K. That's my middle step. Okay, so L is 10. I'm going to solve for K, and this is 512 is for frequency. So when I go to solve for K, I'm going to multiply by 512. And 512 times 10 is 5120. That's what the K value is. That's a really big K. All right, now I'm going to take this equation, rewrite it over here, but putting K in that spot. Okay, so L equals 5120 divided by F. And now I'm going to solve for what I want. Okay, so this one says find the frequency of an 8-inch violin string. Okay, so here I know that this is 8 and I'm trying to solve for F. Okay, I'm trying to solve for F. So I've got 8 equals 5120 divided by F. Well, all right, how do I get F out of here? Well, what I can do is I can multiply by F to the other side, right? So f times 8 is 8f equals 5120, right? Like that's how that works. I can multiply that f to the other side. And then if I want to get f by itself, I could then just divide by 8 and get the 8 to the other side now. And f will be 5120 divided by 8. And I'm going to do that with a calculator. Hold on just a second. 5120 divided by 8. And that is 640 is the frequency for that one. Okay. Ugh, my pen is running out. 640. Okay, so another inverse variation, but with story problems instead. So just find what your variables are and just do those same 3 steps again. Okay, last one is combined variation. Okay, and so when you have combined variation, you're going to have a direct variation and an inverse variation. Oh, come on. Direct and inverse. Let me write that again. My pen is shorting out here. Inverse. They might also call it indirect. Okay, so you'll have 2 kinds of variation going on here. So when you have that, the part that's directly related, so they will say y varies directly with x, but inversely or indirectly with z, right? He's directly related to x, but he's inversely related to z, and that just tells you that the x goes in the top and the z goes in the bottom, so that's combined variation, right? Direct looked like y equals kx, which is what you have here, and inverse was like y equals k over z, which is what you have here, right? So it's like combining those 2 all in one, and that's a combined variation, all right? So here's an example of this. We also see like this one is a kind of an example of could be an example of combined variation. K is temperature, P is pressure, so that's volume equals temperature over pressure. That's a combined variation that you might see in like physics or in chemistry class or whatever. So, all right, same thing again. I have to establish my equation with my variables. So suppose F varies directly. I'm going to start with F. Varies directly with G. That means G goes on the top. And F varies inversely with H. That means H goes on the bottom. And K is going to always be your constant that lives on the top. So we're just going to put him in there. All right. That's my equation. Then we need to solve for what that constant is. We need to solve for K, and then we need to solve for what we want. Okay, let's see what they do to us here. Last problem. Solve want. Okay, find G. Wait a second. That sounds like what we're doing over here. So I'm going to say find G. They're giving it to us backwards again. Oh, I hate it when it does that. Find G. When F is 18 and H is -3. Okay, that's what they're like giving it to us backwards. So this stuff goes over here, and then we're going to use this information to find our K in the middle. So G equals 24, H equals 2, F is 6. Okay, we're going to use that information to solve for K. All right, so I'm going to plug that stuff in. F is 6. Will you stop doing that? I don't know, it's a sign or something. G is 24, and H is 2. There we go. Okay, just like that. All right, I'm going to use that to solve for K. So first thing, let's multiply by 2. If I'm going too fast, you can always pause. I mean, that's totally fine. 12, and K times 24 is 24K. And then I'm going to divide by 24. And 12 divided by 24 is 1/2. Or you could do 0.5 if you wanted to. See, it's doing it again. I don't know why it's doing that. So 0.5 is what your K value is. Okay, we've solved for K. The last thing we need to do is rewrite this guy over here and solve for G. So I'm going to put him over here. All right, we know that F is 18. It's doing it again. Will you stop? 18 equal. All right, let me hook him on here. Let's see if we can get through this. 18 equals, nope. I don't know. 18 equals, all right, so that's F. K we know is 0.5. He goes on the top. We're trying to find G, so he goes here. So 0.5 times g, and then h goes on the bottom, which is negative 3. All right, then we just have to unwind and solve for g. So I'm going to, let's see, multiply by negative 3. 18 times negative 3 is negative 54. You check that and make sure that's right. I'm pretty sure it is. Okay. And then this is negative 54. This is 0.5g, and then we're going to divide by 0.5. Okay, divide by 0.5. And if you take negative 54 divided by 0.5, it's like negative 108, I believe. And that is what our g value is. So that's solving for what we want. Okay. All right. So same 3 steps every single time when you go through. Not too terribly bad. Okay. Sometimes they give it to you in a backwards order, like they did to us a couple times. So beware of that. All right. Do odds on both sides, it looks like. So odds and odds. All right. That's only 1 story problem instead of 2, kind of. Okay. All right. So there you go.